Welcome to this video on the 5 key terms used in any study that employs statistical methods. Often introduced within the context of advanced topics like parameter estimation or probabilities, these terms may seem familiar, yet they often lead to uncertainty in their application until later in the academic year. Let's start with population. This term in statistics differs from its everyday use. It refers to the set of all observations or data points with a specific common feature. For instance, the set of students that learn Greek as a second or foreign language, they can also be called L2 Greek learners, can be considered a population. Each student that belongs to that set, with measurable attributes like age or proficiency level, is a data point. This data can be recorded and analyzed with R. Populations can be broad, like all the undergraduates in a country, or they can be specific, like students at a particular university in 23. Whether we can enumerate the population's members or not varies. Some populations, like the undergraduate students in a given year, are countable, while others, like all native Chichewa speakers across time, are more theoretical and cannot be fully enumerated. In reality, accessing every member of a population is often impossible, especially for theoretical populations. Hence, we collect samples, smaller groups representative of the larger population. This process, known as sampling, is crucial in research. Now, there is an ambiguity related to the term sample that confuses almost all beginners, including me, when I entered the subject. A sample can be either a single data point, so when we refer to it we mean a single data point like a single student, or we use it to denote a whole set of points from the population that is used to test hypotheses and estimate effects. Don't worry about these terms, we will spend time later on them, and we'll explore sampling strategies in more depth in future videos. Moving on to parameters. A parameter is a quantity describing an aspect of the entire population. For example, the average age of all L2 Greek speakers currently living all over the world is a parameter. The population variance, the population standard deviation, and in general any quantity related to the whole population is a parameter. In studies encompassing all historical speakers of a language, for example, parameters such as the population mean, variance, or standard deviation consider every speaker who ever existed, and that makes them entirely theoretical and inaccessible. In contrast, a statistic refers to a quantity that describes a feature of a sample, essentially serving as the sample's equivalent of a parameter. Typically, we aim at approaching or estimating a parameter, and when examining a specific parameter, all one has is a sample from which the parameter is to be estimated. And by sample here, I mean a set of data points collected from the population. This process of estimation is a key element of statistical analysis. Most studies want to estimate one or more population parameters using one or more statistics. So, as the analysis of a statistic can be viewed as a method for approximating the theoretical concept of a population parameter, which is almost like a godly granted construct that we don't have direct access to. Lastly, distribution refers to how sample data values are spread. It's important to understand this spread to analyze data effectively and to interpret the data qualitatively. For example, knowing how many L2 speakers of Greek belong to each L1 helps us understand our sample's composition. A distribution is nothing else than a function that takes all the possible values that a variable can take. In our example, that would be all the recorded first languages of the L2 speakers in our sample as its input, and outputs the number of speakers that belong to each of these first languages. Distributions can be visualized in graphs, like bar plots in R, showing the frequency of each L1 among the learners. For numerical variables, things are slightly different. We need to refer to ranges of values and to data density instead of frequency. But dealing with the distribution of numerical variables will be the topic of one of the next videos. These 5 terms are pivotal for understanding basic to advanced statistical methods in language data analysis. So, stay tuned for more detailed discussions on basic statistical concepts and of course on using R for doing stats. Until next time, happy R coding!